Welcome to this lesson on linear equations and inequalities. In this video, we will explore how to solve and graph both linear equations and inequalities. Let's get started. A linear equation is an equation that forms a straight line when graphed. It's typically written in the form ax plus b equals 0, where a and b are constants and x is the variable. To solve a linear equation, our goal is to isolate the variable x. This is done by performing inverse operations to get x by itself. So some steps to solve are first to simplify both sides of the equation. You want to combine the like terms and remove any parentheses if it's necessary. The second step is to isolate the variable. You want to use either addition or subtraction to move terms with variables to one side and constants or just regular numbers to the other side. And lastly, you want to use either multiplication or division to actually solve for x. Let's look at an example. The first example says 2x plus 5 equals 13, and we want to see what x is. Again, the first step, we're going to subtract 5 from both sides. So on the left side, we're going to subtract 5, and the right side, we're going to subtract 5. On the left side, the 5 and the negative 5 will cancel out, giving us 0. And then on the right side, we're left with 13 minus 5, which is 8. Now we have 2x equals 8. Now we're going to divide both sides by 2, since the 2 and the x are bound by multiplication. When we divide the left side by 2, we get just an x because the 2's cancel out. On the right side, we're going to do 8 divided by 2, which is going to be 4. So the solution is x equals 4. Let's look at a second example. In this case, we have 3x minus 7 equals 11. So the first step, we're going to add 7 to both sides because we have to do the inverse operation. So on the left side, the negative 7 and the plus 7 will cancel out, giving us 0. But on the right side, we do 11 plus 7 and get 18. If we rewrite our equation now, we get 3x equals 18. Now again, since the 3 and the x are bound by multiplication, we're going to divide them both by 3. When we divide the left side by 3, they cancel out and we just get an x. On the right side, we're going to do 18 divided by 3 and get 6. So this solution is x equals 6. Now let's look at linear inequalities. A linear inequality is very similar to a linear equation, but instead of an equal sign, it uses either a greater than, less than, greater than or equal to, or less than or equal to sign. To solve linear inequalities, it's very similar to solving linear equations, but there's one important exception. When you either multiply or divide both sides of the inequality by a negative number, you have to reverse the inequality sign. So if you have a greater than sign, you're going to flip it and make it a less than sign. Let's look at an example. In this case, we have x plus 3 is less than or equal to 7. In this case, we're going to do just like what we do for the equation and subtract 3 from both sides. Once we do that, it cancels out on the left side, and on the right side, we get 7 minus 3, which is 4. So our final solution is x is less than or equal to 4. Let's look at one with the exception. This example has negative 2x plus 4 is greater than or equal to 8. So again, the first step we're going to do is subtract 4 from both sides, canceling out on the left from the plus 4 and the minus 4, and on the right side we're going to get 8 minus 4, which is 4. Now if we were to rewrite it, we're left with negative 2x is greater than or equal to 4. Now we're going to divide both sides by negative 2. Since we're dividing by a negative, we have to flip the sign. So we're going to be left with x is less than or equal to 2. Let's look at graphing linear equations. To graph a linear equation in the slope-intercept form, which is y equals mx plus b, you're going to need two things. The slope, which is represented by m, that tells you the steepness of the line, and the y-intercept, which is the point where the line crosses the y-axis. I will leave a video going over slope and y-intercept in the comments. This example says y equals 2x plus 1. The first thing we're going to want to do is identify the y-intercept and plot it. In this case, the y-intercept is going to be at the point 0, 1. So on our y-axis, we're going to go up 1 unit and plot a point there. From there, we're going to look at the slope, which is 2, or 2 over 1, and plot the next point. So since the slope is rise over run, we're going to go up 2 units and over 1 unit to the right and plot a second point at 1, 3. Now we can draw a straight line through these points and complete the graph. To graph a linear inequality, something similar to the last one, we have y is less than or equal to 2x plus 1. thing we want to do is graph the boundary line as if it were an equation such as y equals 2x plus 1. It's a greater than or less than sign, we're going to have a dashed line, but if it's a greater than or equal to or less than or equal to, we're going to have a solid line. So in this case, our line is going to be solid. Then what we would do is we would shade the region that satisfies the inequality. This inequality specifically is saying that y is less than this line. So we have to look at our y values, which remember, it's our units going up and down, and see which ones are below the line, and we would shade all of them in. Thank you for watching.